Welcome to the Explainer. Today, we're cracking open the digital toolbox. We're going to take a look at one of the most fundamental pieces of tech out there, something that powers, well, pretty much everything you do online, the database. All right, so let's just jump right in. This is the big question, isn't it? I mean, you've got so many options out there. You've got the giants like Oracle, newer tools like MongoDB. So why? Why hasn't one single perfect database just shown up and taken over everything? Well, the short answer? Different problems just need different tools. Think about the absolute tidal wave of data that modern apps create. Every single click, every photo you upload, every transaction you make. It's just way too much and way too varied for any one-size-fits-all solution to handle. You need a specialized home for each kind of data.
Okay, so let's start with a classic, the foundation, really, of the digital world. This is the most traditional and widely understood tool in our toolbox, the relational database. You can think of it like that reliable, all-purpose wrench you can use for pretty much any standard job.
The whole idea here is structure, pure, simple structure. A relational database is kind of like a perfectly organized library, but instead of books, it's got spreadsheets. All your data is kept super neat and tidy in tables, and the relationships between those tables are clearly defined. And that's absolutely critical for what we call data integrity, which just means your data stays accurate and consistent no matter what. And this slide right here, it shows you that exact concept in action. See, on the left, you've got a table of customers. In the middle, a table of their orders. And that customer ID column, that's the magic glue holding it all together. It makes sure every single order is tied to a specific customer. That's how you build a reliable, interconnected system. And this kind of structure, it's perfect for jobs where reliability is totally non-negotiable. I'm talking about things like managing your bank account, right? When you transfer money, you might hear this term thrown around, ACID transactions. It's an acronym, but it basically guarantees that a transaction is atomic, consistent, isolated, and durable. You know, in plain English, it just means the entire operation either works perfectly or it fails completely. There is no messy in between. Because in systems like these, you just can't afford a single mistake. But then the internet just exploded, right? Data got bigger, it got way messier, and it started moving so much faster. Suddenly, that trusty old wrench wasn't always going to cut it. We needed a whole new class of tools, the high-powered, super specialized tools we now call NoSQL databases. So here's the crucial point. It's all about the trade-off. On one side, you've got SQL, our wrench. It gives you that rigid structure and rock-solid consistency we talked about. A transaction is either perfect or it doesn't happen. On the other side, you've got NoSQL, our power tools. They trade some of that rigidity for just incredible flexibility and the ability to scale out, which means you can just spread the load across a ton of cheap machines to handle truly massive data sets. So first up in our NoSQL family is the key value store. This thing is built for one thing and one thing only, pure, unadulterated speed. You give it a key and boom, it instantly gives you the value back. This makes it the absolute perfect tool for things like caching, storing data you need to access all the time, or keeping track of user sessions on a website. All right, next up we have document databases. Now, I want you to imagine that each record isn't a row in a table, but its own self-contained folder. And inside that folder is all the data it needs stored in a super flexible format, like JSON, which is really just a simple way to organize data with text. This is fantastic for things like e-commerce product catalogs, where, one product might have totally different features than another, or for content management systems. Now this is a totally different way of thinking. Graph databases. Forget tables, forget documents. These things are all about the relationships between your data points. They see the world as a huge network of nodes, which are the things, and the connections or edges between them. And that makes them the ultimate tool for mapping out connections. Just think about it for a second. What is a social network? It's just a giant graph of people and their friendships, right? And how does a recommendation engine work? It works by finding all the hidden connections between you, the products you look at, and what other people like. It's all about that web of relationships. And finally, in the NoSQL world, we've got wide column stores. Okay, these are the heavy lifters. They are built from the ground up to just absorb and query absolutely enormous streams of data at insane speeds.
So if you need to track every single click on a massive website or process data pouring in from millions of Internet of Things sensors, like your smart thermostat or industrial monitors, this is the tool for the job. All right, let's head over to the specialist's corner of our toolbox. We're done with the general purpose stuff. Now we're talking about the precision instruments. Each one of these is engineered to perfection for one very specific and usually pretty complex job. I mean, just look at this incredible lineup. Each one of these is an absolute master of its own domain. Take time series databases. They're optimized for data points that are recorded over time, like tracking stock prices second by second. Or spatial databases. They're what power the map on your phone because they understand geographical data. Or check out vector databases. They're the secret sauce behind a lot of modern AI, letting systems find images that are visually similar to one you just uploaded. Every single tool here, from Ledger to in-memory, solves a very specific and very tough problem.
Okay, so you've got this massive toolbox. It's filled with wrenches, power tools, and all these crazy precision instruments. The question is, how on earth do you pick the right one for your project? How do you even start to think like a system designer?
And this right here is probably the most important thing you'll take away from our entire explainer today. There is no single best database. It just doesn't exist. There is only the best database for the specific job you need to get done. And honestly, anyone who tells you different is probably trying to sell you something.
It all comes down to asking the right questions. What does your data actually look like? How fast do you need to get to it? How big do you expect it to grow? And here's the big one. What are the trade-offs you're willing to make between having perfect consistency and having lightning-fast performance? And that leaves us with one final thought to chew on. As things like AI, the Internet of Things, and, well, technologies we hasn't even dreamed up yet, as they start generating even more complex and interconnected data, what's next? What will the next incredible, mind-bendingly specialized tool in our database toolbox even look like? Because this evolution, it's far from over.